Good morning.
Hello.
Good morning.
Good morning.
How are you?
Good afternoon.
Oh, good afternoon. How are you?
I'm good.
Yeah, I'm also good. So today we're going to start a new chapter. Have you covered this chapter already at school?
Ayikho kubonakala. I think one sa nta.
Okay. We are going to do a chapter of trigonometry. So I would like to find out if you have done this chapter at school already. Have you done this chapter of trigonometry from school? Have you done trigonometry from school already? Or is for the first time?
Trigonometry, the tree.
Trigonometry. Okay, yeah. So remember, I will have to explain in detail. Now this is one of the important chapters. Let me put a star here, like what I've done under Euclidean geometry. So if we talk about mathematics paper 2, it relies on trigonometry. It also relies on Euclidean geometry. So you must make sure you understand these two important chapters. So today we're going to do trigonometry, which also play a crucial role in paper 2, in maths paper 2. So I'll try to explain everything in detail, and I'll be slow so that you understand everything which I'm going to explain. The approach we use in order to deal with questions under this trigonometry chapter is the same approach we use for Euclidean geometry. So we need to understand certain principles in order to solve certain problems. In Euclidean geometry, we have to understand the theorems in order to solve the questions. So in this case, we need to understand a lot of things. We need to understand a lot of things in order to solve certain questions. The very first thing which you must understand is what is called trig ratios. So we must know about the trig ratios. We must know about the identity. We must know about the Cartesian plane with the reduction angles. We must know about the special angles. So those are the things which will assist us in order to solve any question under trigonometry. Emphasize talk. Uri ri kone u solve question iṅwe na iṅwe ine yavha under trigonometry, zwi ṱoḓa uri ri vhe na zwithu zwine ra zwi ḓivha u thoma before ri sathu thoma u solve question. So tshithu tsho thoma tshine ra tea u tshi ḓivha ndi zwine ra zwi vhidza uri trig ratios. So dzine trig ratios dzi tshimbila na correlation, and then again ri tea u ḓivha dzi identities nadzo dzi ri thusa u solve dzi questions dza trigonometry. Tea u dovha ra ḓivha Cartesian plane ine ya ḓa ina dzi reduction angles. So and then ra tea u dovha ra ḓivha Pythagoras, and then ine ya ḓa Pythagoras i ḓa na dzi special angles. So hezwo zwithu ndi zwone zwine ndi ḓo thoma ngo introduce zwone, and then from there ra kona u fhindula dzi questions. So ri ḓo thoma nga zwo thoma zwine ri zwi vhidza uri dzi trig ratios. I will explain uri ri tshi ri dzi trig ratios ri vha ri khou amba nga mini. So now trig ratios, remember trigonometric ratios, of which ratio a fraction. So now, trig ratios are the apply shape in a right angled triangle. So if a right angled triangle are in a 90-degree in one of these three angles here. So let's say we have a 90-degree there. Therefore, we have a right angled triangle. So if we have a right angled triangle, therefore, jambo ringakono apply the trig ratios. So now let's name these sides. Let's say we have angle theta here, and then down here we have angle A, and then up there we have angle B, and then this side we have angle C, like this. So on this right angle triangle, we have an angle theta, and then we have angle A, and then we have angle B, and then we have angle C. So these sides, all these sides, they are having names. For example, side A, we call it the adjacent. So that is what is called the adjacent side. And then angle B is what is called the opposite side. And then side C is what is called the hypotenuse. So these are the names. These are the names we encounter on the right angled triangle. So let me explain about these angles here. So now this A is the adjacent side to angle theta. This A here is the adjacent side to angle theta, to this theta we have here. And then the B is the opposite side to angle theta. So if you observe, you will see that indeed the B is opposite to angle A. And then the C is the hypotenuse side to angle theta. So that is very important. So you must be able to understand that, for an example, if we are not given theta to be the angle in that region, let's say we now have theta which is in that region. Can any one of you tell me what will be the adjacent side when the theta is up here? If it is no longer there, what will be the adjacent side on this triangle?
B.
Side B.
B, yes. And what is the opposite side?
A.
And then the hypotenuse?
C.
I'm very happy that you were able to spot that out because it's very important. So some questions, they may play this game wherein instead of giving the angle down here, they decide to give an angle there. So you must be able to see which one is the adjacent, the opposite, and the hypotenuse side. So, but for the sake of explaining topic, I will use angle theta, which is down there, of which means A is the adjacent, B is the opposite, C is the hypotenuse. Remember, we are focusing on what is called the trig ratios. So now, trig ratios, we are referring to a function which is called sine, and the function which is called cos, and the function which is called tan. So these are the trig functions. These are the trig functions. So it's function sine, function cos, and function tan. But these trig functions, we can write them in terms of ratio, of which this word ratio is simply meaning the fraction. So it's the fraction. So the sine theta, we can write it in terms of fraction. And I'm going to give you the fraction of sine theta. So sine theta at all time is given as the opposite side divided by the hypotenuse.
Hypotenuse.
Change. Yes, you must remember this because it doesn't change. Sine theta is equal to opposite over hypotenuse, of which we are given the opposite side and the adjacent side and the hypotenuse. So on this question, you will see that the opposite side is B, and then divided by
B.
the hypotenuse side, which is C.
C. C.
So that is important information which you must take note of. We can quickly go to the second one, which is cos theta. So cos theta is adjacent over
Adjacent.
hypotenuse, right?
Hypotenuse.
Of which in this case adjacent is what? It's
A.
A. And then you divide this A by hypotenuse, which is C. Is that clear?
C. Yes.
All right, and then again, we can do the same for tan, of which is given as the opposite over the adjacent.
This
Case opposite
adjustment.
given as B, and then adjacent is given as what? Is given as A. So this is very important in order to answer questions under trigonometry. So you must understand this, which we call the trig ratios. And trig ratio, take note of the fact that we use it when we are having the right angled triangle. I hope that statement is clear. So now, there are other notations we use or other functions we use besides sine, cos, and tan. So the first, let me start with cosec. So we have cosec, of which cosec is the same as 1 over sine theta. We also have what is called the sec. Sec theta is equal to 1 over cos theta. And the last one is cot, of which cot is the same as 1 over tan theta. So there's a relationship between these first three functions with these other three functions here. So the relationship is that cosec is the inverse of sine, and then sec is the inverse of cos, and cot is the inverse of tan. And then this is how we can be able to write cosec in terms of sine. So it's 1 over sine. Sec is 1 over cos, and then cot is 1 over tan. I would like to find out from you if that explanation is clear to all of you.
Yes.
All right, wonderful. So with the background I've given you just now, you may be able to answer some of the questions under trigonometry. So with trig ratios, it enables you to answer some of the questions under trigonometry. So, but before we go to the questions, I would like to cover the second important topic on trigonometry, of which is called the identity. So you must be able to give what is called the identities. So now, what are the identities? In your grade, you don't do a lot of identities. It's only 2 identities that you must remember. It's only 2 identities that you must remember. So the first identity that you must remember is the identity of tan. So tan theta, instead of writing it as opposite over adjacent, you can write it as sine theta over cos theta. So that is the first identity. Whenever you see tan theta, you are allowed to write it as sine theta over cos of theta. You can even prove that to validate that indeed tan theta is equal to sine theta over cos theta. And then the second identity you normally use in grade 11 is the identity of sine squared theta plus cos squared theta, which is equal to 1. Whenever you add sine squared theta plus cos squared theta, this is going to give you a 1, regardless of the angle given. It may be 30, it may be 60, it may be 90. If it is sine squared, certain angle plus cos squared, certain angle, then you must know that is going to be equal to 1. It's another important identity that you must take note of. So that is the second identity which you must take note of. And we play around with this identity, the second identity, wherein we can take cos squared theta to the other side, and we have sine squared theta as the sum of the formula. And we also take sine squared theta to the other side so that cos squared theta, it becomes the sum of the formula. Let's do just one of these so that you see how we play around with the second identity. So sine squared theta will be equal to 1 minus cos squared theta. That will be after taking cos squared theta to the other side. So it will give you this other identity. It's just a matter of playing around with this identity here, of which they usually like to do that. So now this is the second part, which will help us to answer many questions, especially those questions which requires you to prove. You will come across questions which require you to prove that left-hand side is equal to right-hand side. So those questions you will be able to answer by using these two identities were given on the board. Is that clear to all of us?
Yes.
All right.
Mm.
So now I'm now going to the third section, which is very important. We are going to the third section, which is very important. That is about reduction angles. Remember, these are the keys. Like a screwdriver, you can't be able to take out the lock without having a screwdriver. So screwdriver is a tool. So I'm now giving you a tool here to solve specific problem. So these are the tools. It's the screwdriver and a hammer. So I'm giving you screwdriver and a hammer to solve a certain problem. So now this is the third tool. Is the third tool to solve a trigonometric question, which is called reduction angles. So is the reduction angles. So what are the reduction angles? Reduction angles, they go hand in hand with Cartesian plane. So we must have a Cartesian plane, of which in this Cartesian plane, you must know at all time that this is your first quadrant, and this is your second quadrant, and this is your third quadrant, and this is your fourth quadrant. So this does not change. You will never come across a Cartesian plane which have a first quadrant here. First quadrant is this one here, and this is the second quadrant. This is the third quadrant, and that is the fourth quadrant. There are reasons why we say that. It's just that it's a lot of things which I may not be able to explain now. So on the first quadrant, all trig ratios are positive. Let me repeat this statement, that on the first quadrant, all trig ratios are positive. So if we talk about the trig ratio of sine, we talk about the trig ratio of cos, we talk about the trig ratio of tan, all these three trig ratios are positive on the first quadrant. And then on the second quadrant, it's only one trig ratio which is positive. Which trig ratio is that which is positive on the second quadrant? Is the trig ratio of sine. And then on the third quadrant, again, it's only one trig ratio which is positive, of which that trig ratio is a tan. And then on the last quadrant, it's only one trig ratio which is positive, of which that trig ratio is a cos. So this you must not forget. It's all about the reduction angles. And let me also give you the angles which we found on the four quadrants here. So on the first quadrant, we have an angle of 90 degree minus theta. 90 degree minus theta, we find it on the first quadrant. Why do we find it on the first quadrant? Because you will see that the distance between the x-axis and the y-axis, it gives an angle of 90. So therefore 90 is the maximum angle. So, but in order to generalize all the angles inside the first quadrant, we say 90 degree minus theta. Is that clear to all of us?
Yes.
Mm.
All right. And then the second, I'm going to give you the second angle here. You will have to give me the remaining angles that we can have in this case. So the angle we can find on the second quadrant, we can have 90 degree plus theta. Why is 90 degree plus theta? Because is this 90 degree plus certain angle of which that will bring us to the second quadrant. So 90 degree plus theta, we find it on the second quadrant. Can you tell me another angle we can find on the second quadrant?
180 minus theta.
Very true. 180 minus theta we find on the second quadrant, because 180 is this angle here. So it means 180 is the maximum angle. But for us to generalize all angles inside the second quadrant, we say 180 minus theta. And then on the third quadrant, can you tell me which angles we can find on the third quadrant?
180 plus theta.
180 plus theta.
Very true. 180 plus theta we find on the third quadrant. And then do we have another angle we find on the third quadrant?
270 minus theta.
Yes, it's 270 minus theta. Which angles do we find on the third quadrant?
360 minus theta.
Yes. And then the other angle?
270 degrees plus theta.
Yes. On the third quadrant, we have 3 angles. Can any one of you tell me the third angle we find on the fourth quadrant? Is negative theta. That is another angle we find on the third. So that is what is called the reduction angle. You must keep it in your head. You never have to forget it even a single day, because that is what will assist us to answer some of the questions. So when we are still under reduction angles, I would like to give what is called the core ratios. I would like to give what is called the core ratios. Because core ratios, they have a direct link with the reduction angle. So now the core ratios, we are referring to angles like a 90 degree, it's a core ratio, and 270 degree are core ratios. So what do these core ratios do? What does core ratio do? Core ratio, they change sine to cos, and they change cos to sine. You must be very careful about the core ratios. Otherwise, beside core ratio, there is no any other thing which can change cos to sine and sine to cos. So how do we find those core ratios? Let me do just a few examples here so that you see how we deal with core ratios and how we deal with reduction angles as well. So now let's say we are given sine of 90 degree minus theta. How do we deal with sine 90 degree minus theta? This is how we deal with this situation. So we come and check on which quadrant do we find 90 degrees minus certain angle. Can any one of you tell me which quadrant do we find the 90 degree minus?
First quadrant.
It's on the first quadrant. That's where we find 90 degree minus. And on the first quadrant, all trig ratios are positive. So therefore, here we have a trig ratio of sine, which means it's going to be positive because it also belongs to the first quadrant. And that's the first thing. The second is that we have to check what kind of angle we are given in this case. We are given a 90 degree, of which is under a core ratio. What does core ratio do? It changes sine to what? To cos. Therefore, we're going to have cos of theta. You no longer write 90 minus angle. This only helps us to get the sign here. 90 minus is on the first quadrant, which means we have a positive value. Therefore, it's positive cos of theta because 90, it changes sine to what? To cos. I hope that explanation is clear. I would like to give the second question so that we apply exactly the same thing and see how it works. Let's say we have a cos of 90 plus theta. So we check, where do we find 90 degree minus angle? On which quadrant do we find 90 degree plus angle?
Second quadrant.
On the second quadrant. And on the second quadrant, which trig ratio is positive?
Sine.
Is sine. Do we have sine here? We don't have sine. So that means the answer we're going to obtain is what? Is negative. And then we check which angle do we have here. We have a 90 degree, of which 90 is what? It's a core ratio. Therefore, that means cos is going to change to what? To sine. Hence, cos 90 degree plus theta is equal to negative theta. Is that explanation clear to all of us?
Yeah.
Let me do other ones which are not a core ratio. Let's say we have cos of 180 plus theta. Can any one of you tell me what may be the answer of this one, which is not a co-ratio? 180 is not a co-ratio. Can you tell me the outcome we're going to get for that specific question?
Negative cos theta.
We are going to get negative cos theta. That is correct. And I would like to explain why do we get negative cos theta. Because 180 degree plus, we find it on the third quadrant. And on the third quadrant, tan is the only one which is positive. And here we have cos. Therefore, it means we have to have a negative answer. And because this is not a cos, it means cos is not going to change. Therefore, we have negative cos theta. Is that clear to all of us?
Yes.
All right. We can also try
Uh,
tan 360 minus theta. Can any one of you tell me what may that be equal to?
Negative tan theta.
That will be equal to negative tan theta. So we check the quadrant. 360 degree minus is on the third quadrant, and on the third quadrant, on the fourth quadrant, cos is positive, but here we have tan, therefore we have to have a negative. And then we check which angle do we have here. We have 360, which is not a co-ratio, therefore tan is not going to change, hence we have negative tan theta. I hope that explanation is clear. We can then move forward to the fourth tool. Remember, I'm giving you tools here, screwdrivers, hammers, and stuff like that. So these tools are for solving trigonometric problems. So, but screwdrivers, spanners, and hammers, they are for solving other problems. Ne? Here we are solving mathematical problems. We're not solving other problems. So now we are going to the fifth property, which is special angle. You can see it's also having a special name. So it's a special. So it means we have other angles which are not special. Uh, Here we are dealing with the special angles. So what are special angles? So special angles are given in a right.
yeah.
So a right angle is having a 90 degree at all time. And let me write two right angle triangle because we will be dealing with two kinds of special angles here. So the first is when we are having a 60 degree here and a 30 degree there. So when you add up these values, when you add up these angles, they must give you 180 at all times so that it satisfies that condition which say angles inside the triangles, when you add them up, they must give you 180, or the sum inside a sum of angles inside the triangle, they must be equal to 180. So that same principle must apply here. So it's 90 degree plus 60 plus 30, which is 180 degree. Therefore, this satisfies the condition for that period. So, but we have a 60 degree, which is a special angle, and we have 30 degree, which is a special angle. So again, we also have a special angle of 45 degree here and a 45 degree here. These are the special angles. Beside these, there's no any other special angles in mathematics. We only have this, which we call special angle. So now, special angles are given their sides. They are given their sides at all times. So other angles that are not given sides, you must calculate by using trig functions. So, but here we have a sides. So now we will have one here and we'll have two there. And then here we're going to have root of 3. So you must know this by heart. And then again, here we have 1, and then we have 1, and then here we have root 2. But scientific calculator does this for you. You don't need to cram this because scientific calculator may do this for you. But if you don't have scientific calculator, then you must know this by heart. And it's also very important for you to understand these kind of things. Your special angles are important. We can't answer some of the questions without having a special angle. So then now, I believe we are all clear with regard to this. Yes.
But though,
Yeah.
arali ofi ka exam or ka test ofi without the use of a calculator, and then if ndan songo draw with a triangle banka simpedzing or mark because vadavo vononga ndo shumisa calculator.
Yeah, you need to show that diagram so that you can convince them, or you did not choose a calculator. So you can just show them that you understand what you are doing.
Oh.
Yeah. So my advice would be
Okay.
show them the diagram, and then that's when they will see, or you know what you are doing, and you did not use a calculator. Yeah, because in this chapter, there are some questions which say without the use of a calculator. So in that case, it means you must know special angles so that they don't. There's a strategy where they see that this person have used a calculator, this person did not use a calculator. There's a strategy they use to detect such kind of. And one of the things you do when you omit this diagram, so they may see, oh, this person is trying to cheat us, and then they may not give you full marks. So now let me just do few angles which are special in this case. So let's say we have cos 60 degree. So we have to check, where do we have 60 degree here? So 60 degree is down here, of which we know cos is adjacent over hypotenuse. So on this diagram, adjacent is 1 and hypotenuse is what? It's root of 3. Therefore, cos 60 is equal to 1 over root of 3. Do you see that? So the answer for cos of 60 is equal to 1 over root of 3. Is there any one of you who
Wait, Bondo, ka inwe drawing inwe hapana ni atidebro kaka neti, but ka yona ni triangle your trauma is 60 degrees. Square root of 3 I could over a opposite side.
Square root of 3. Is there any one of you who have a calculator there who can verify what you are saying with a calculator? I might have done
Yeah, the calculate.
Yeah, what is cos 60 degrees?
Meaning cos or sine?
Cos 60 degrees.
Cos 60 degrees.
Yes.
The 1 over 2.
1 over 2. Yes, you are right. Okay. So the 2 is here.
Okay.
Then the root of 3 is down. Okay. That's very true. You were right. So let me try to validate what I've done there is correct. We can validate with the Pythagoras theorem. So we have 3, 1, which is equal to r squared. And then we have r squared equal to 4, therefore r is equal to 2. Yes, that is correct. Thank you for correcting me on that one. So now it means cos 60 is 1 over 2. So now let's do sine 30 degrees. Can anyone of you tell me what may be the value or the fraction of sine 30 degrees?
It'll be 1 over 2.
1 over 2.
1 over 2 again. So I'm very happy that you are able to read this diagram. Let's do these two last ones. So the first one is cos here. Cos 30, and then let me also do for tan 8. So cos 30 degrees is equal to what?
Square root 3 over 2.
It's square root of 3 over 2. Wonderful. And then what about tan 30?
1 over square root 3.
It's 1 over root of 3. This is good. We can do the same on this one, but here it's when we are having 45. So let's do for cos 45 and sine 45 and tan 45. So tan 45, let's start with cos 45. Cos 45 is equal to what?
1 over square root 2.
Cos 45 is equal to 1 over root of 2. What about sine 45?
It's gonna be 1 over square root 2.
And then the last one?
It's gonna be 1.
Well done. So this is important information I've given you, but I will make a big mistake if I don't give you what is called Pythagoras theorem. This is the very popular theorem which you will come across from now until you go to university. This theorem doesn't change. We use it even at PhD level. It doesn't change. You go to mathematics, you go to engineering, you go to accounting, they will be talking about the Pythagoras theorem. So now Pythagoras theorem is given as x squared plus y squared equal to r squared, wherein x is the adjacent, y is the opposite, and r is the hypotenuse. So you must not forget the Pythagoras theorem. I hope we are together up to this point. Is that so?
Yes.
Wonderful. We still have about
20 minutes.
we still have about 20 minutes. I prefer that you guys come up with questions that we can do together. So you may look for questions that we can attempt to with this remaining 20 minutes.